Hi guys, welcome to lecture 2. So today I'll be covering n-gram models. So I have written some dum dummy text for you. So guys, see, the main idea that we need to focus on is whenever it comes to modeling, right? Whenever, let's say you ask ChatGPT to summarize a text. So in its backend, the problem statement given to it is next word prediction. And essentially we'll be also focusing on this only, that is next word prediction. So based on the text that is given to you, you need to predict the next word. That's the simple thing, and on those lines only n-gram models are also there. Obviously, as I said guys, we need to quickly reach to LLMs. So LLMs don't use n-gram models in any ways. This is very outdated technology, but just giving you a glimpse of how uh, previously textual data was modeled. So we have this data. This is start of sentence token and this is end of sentence token. Okay, the cat sat on the mat, the dog played in the yard, the cat chased the mouse, the dog barked at the cat. Now what we need to do is we need to predict the next word that would come after the, and for this we'll be using unigram model. So unigram model is very simple, right? In simple terms, it is probability of word divided by n. Okay, so what are the words which are essentially there? So essentially the words which can come after the, based on the data set that we have, are, but the thing guys here is that we are talking about unigram models. Okay, so in unigram model all you need to do is you need to just have this thing calculated for words. Okay, so let's say you need to calculate this, and the main problem statement that we are dealing with is what is the next word which will come after the. Okay, so let's start with cat. Let's assume cat will come. So what is probability of cat? Probability of cat is, first of all we need to get n. What is n? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23. N is done. Now what is the occurrence of this word? 1 2 3, 3 by 23. Similarly you can calculate, let's say you assume mat would come. So n is fixed 23. What is the probability of occurrence of mat? 1, only 1, so 1 by 23. So you're able to see guys, similarly you can compute probability for any word, and for the time being I'm assuming this is the maximum occurrence. So based on a unigram model, which is simple probability model, okay, based on unigram model, what would come after the cat? Now we'll be talking about main thing, which is bigram model. So usually guys, people discuss this bigram model a lot. What happens in bigram model is that the prediction would be based out of cat. What does that mean? That this word would be based out of this word. So probability of next word, not sure which word would be, but it would have some association with cat. So what can be those words? So let's just try to see a data set. So sat is there, hmm, and chased is there, okay, and end of sentence token is there, right? Because this need to be occurring after the cat thing. The thing is, right now we are talking about bigram models, so n is 2. So the next word prediction, would depend on what? It would depend on previous word. So this is the next word which we wish to predict, and that would depend on cat. So let's compute the probability of the sat cat. What is this probability, guys? Tell me. First of all, you need to see the occurrence in which you are talking about cat. So it's 1, it's 2, it's 3. So this would be 3 sat. So when cat and sat are together, this way they are together in any sentence they are there? No, they are not there. So 1 is there. Which is the next word in the corpus that comes after cat? Chased. So probability of chase given cat, what that would be? So again there is only one combination in the corpus, so 1 by 3. Again probability end of sentence token given cat would be same as 1 by 3. So guys, this is a very small corpus of data that I have taken, but in real life, as I said, you won't be doing it, but still you have large set of corpus. So essentially what happens is that you tend to predict it based on the subsequent word. So the thing is, we are talking about bigram, so n is 2. Now the next word prediction problem would depend on the last word. So as I said that the problem is the cat, what should come on the next. So this prediction would depend on next here over here, like this dash, whatever is the next word would depend on the previous word cat. And we calculated, okay, cat comes 1, 2 and 3 times, so we computed the probabilities of the word which are next to cat, and we got that all three have equal probability, so any one you can choose. Okay, for my thing I'm choosing sat, so the cat sat. Now the next word, now let's use trigram models to predict it. Trigram, so guys, trigram n is equal to 3, so two words would be responsible for predicting the next word. So this prediction would be next word would be cat sat. Now we need to figure out how many times cat sat is occurring in the data set. It's only occurring once. So guys, anyhow, the word that is after it would be on only, because there is no other word in our data set because of limited condition, and probability is 1 only because 1 by 1 is 1. So there is no word in our data set. So the next word that would be the cat sat on. Now guys, try to understand what are we trying to achieve and what is the objective over here. We are talking about n-gram models. Okay. What is the problem statement? The problem statement is this one, that is next word prediction. Why this is the problem statement, guys? Because this is how the statistical process is designed. Now the thing is, we need to talk about unigram. So unigram is simple, guys. Just check what is the, so we discussed that, let's say we wish to predict what is the next word after the, so we just need to predict the fact that we need to compute the probabilities of all word. Okay, because it's a simple thing, it doesn't depend on anything, you just need to compute probability of occurrence of each word and the maximum one would come. So that is how we got the cat. Now as I said, we need to predict the next word, so for the time being I'm using bigram model. Now what does bigram model say? That n is equal to 2, so what would be dependent on n minus 1? So it would be dependent on next one word, so cat. So now we took next word cat. Now we need to see that we have cat, we have cat, we have cat. So we looked at the words which come after cat in our data set. Sat comes, chased comes, and this end of sentence token comes, and then we are computing the probabilities. Okay, let's say you would have had one more sentence, the cat sat on the water. So then this would sat cat would, the numerator would become 2 because of occurrence of another corpus which has sat after cat. Then we talked about trigrams. So in trigrams, two words are responsible for the prediction of next word. So the cat sat. So now this is there. So we need to predict this word based on two things. So that's how we did it. Cat sat, and we only had one word occurrence after it, on. So we had to just bet on that only. So essentially, guys, the idea that we are talking about here is that just try to remember these things. The problem is next word prediction, and we used a simple algorithm, next word prediction. The problem is next word prediction. The problem is next word prediction, and for that we use a simple probability based approach, in which we are computing probabilities and trying to predict the next word. So this is known as n-gram models, and the next word would depend on n minus 1 tokens. That means whenever you are predicting the next word, it would depend on n minus 1 token. So essentially in bigram, n was 2, so it depend on one word. In trigram, n was 3, so it depend on 2. Okay, so essentially guys, if you would have read about Markov chain, you don't need to know about that right now, but still. So because of Markov chain assumption only, we try to get this thing done. What does this say is that n, that outcome which occurs at n, would be dependent on n minus 1th state. N minus 1th state. So that's okay if you don't want to remember this, but just try to understand this. So I think now guys it's clear. Try to revise this example and just try to make notes of it, because essentially we are getting started to the problem of next word prediction, and this is an important problem statement that we need to cover, and slowly things will build up. Until then, please subscribe to my YouTube channel, and do follow me also on Instagram and LinkedIn. Thank you, friends.